Okay guys, welcome again to Paul's Karts, and what we're going to talk about today is cylinder head shape and valve shrouding and the ability to increase horsepower through increasing flow through the intake valve into the combustion chamber and down into the cylinder, and what it takes to actually make horsepower. So with that said, let's get into it. Okay. So what we have here is a few different types of cylinder heads. On the left, this is a stock Gx390 head. In the center, there is a Gx390 head that I have modified to what I believe to be the absolute pinnacle of cylinder head shape and design. And on the left, I have a Predator 212 cylinder head that is welded up for high compression. This cylinder head also has larger intake valves, and what we have here is a Predator 212 hemi-cylinder head. So what I want to talk about in this valve is an issue that I addressed in my last video. Now this issue was about valve shrouding. Now valve shrouding, as I explained in the last video, is any area where the valve is too close to the cylinder head wall. So if you see here, if I lift this valve, say 1/4 of an inch, here's a relation to my finger, that's about 1/4 of an inch. If you look at that from the side of the head, that valve is down inside of a cup. And there's an issue that I brought up about the area of the valve that's shrouded and how putting a bigger intake valve doesn't necessarily mean you make more flow. Now in the comments section, I got a lot of feedback from what I believe to be misinformed people. So I just wanted to clarify what valve shrouding is and why that term in the industry came about. Now, I have some books here. One book is called Engine Math. This book here is authored by Jim McFarland. This will be a book that I'm referencing. Another book that I have here is called David Vizard's Port and Flow Cylinder Heads. That'll be another book that I'm referencing. And another book here I have is How to Build Horsepower, Volume 1. Now the reason I'm showing you these books is to illustrate the point I was trying to make in the last video and to clarify some misconceptions of valve shrouding. So, in this book here, as you can see, the title of this chapter is called Valve Shrouding. And the first picture you see is a cylinder head design similar to the one in the center, which is the type of cylinder head that I believe flows better than the cylinder head on the right because it doesn't have shrouded valves. So you might ask, what is valve shrouding? So if you read here, it says the basics of valve shrouding. And as you can see, the valve on the right is unshrouded where the green arrow is, allowing the air to flow past. And what it says beside that is on the left is totally shrouded valve, the one with the red X's. This doesn't happen in practice, but it demonstrates what shrouding is. No air passes by the head of the valve because it's completely enclosed by the chamber walls. By pulling the chamber walls away from the valve circumference, as the one on the right, the air or the green arrows can pass freely around the valve's head. It goes into further explanations about how far around the valve. These are books that I've read in the past. You know, sometimes, you know, you just need to clarify information. So if you don't want to take my word for it, here are some well-known people that made their entire life's work and put it into books. So, you know, dedicated to research, like my channel says, is why I'm making this video. Now, as you see in this picture, the valve on the left with all the red X's, it is very similar to the design of this cylinder head. Now, it even said in this book that it doesn't happen in practice. Well, this is an exact representation of how it does happen in practice. Now, some people call these heads their figure 8 shaped heads, really stand on this as the cornerstone of, their level of engineering and design. I'm not trying to discredit anybody. I'm just trying to bring the knowledge to the masses. What I was referring to, and thought I made it clear in the last video, was that by installing a smaller intake valve would allow this air to flow better. So I was told in that comment section that that was incorrect. So when we have this engine math book, which is another book, we'll flip to this page here. Now, if you can see, this book is all about math and equations, and this book here is a book that I reference back in the day, and basically I built that entire 3-subject notebook off of. So what we have highlighted here is another important thing to consider is saturation point of the port with regards to valve curtain area versus port cross-sectional area. Now, what they're talking about there about valve curtain area and port cross-sectional area is, it doesn't matter how big of a seat you put in. Port saturation, what port saturation is the point at which the port is now the restriction. Within this entire intake cycle, what you're looking for is the straw in the system, or the point of restriction. So just by putting in a bigger intake seat, that theoretically could increase flow. But it can only increase flow if there's a certain number of events in order for that to increase the flow. One of them being that the port is not too small, where that port is now the restriction. It doesn't matter if you put in a 3-inch valve. If you have a 19-inch cross-sectional area, you just can't flow enough air through that cross-sectional area to support that valve. And that's what's referred to as port saturation. I've talked about that in other videos. If you want to look into my playlist of engine optimization, I go into details about all of that, how to choose cam size, how to choose carb size, valve size, etc. Now, another book that I have here to reference is How to Build Horsepower. I will turn to this page here, and this reference here basically sums it up. And it says intake valve size. We can read it from the beginning, not just the highlighted area. Installing a larger intake valve can often be a worthwhile way to increase port flow and horsepower. The main obstacle here is the limited space between the valves to allow the use of a larger valve diameter. But beyond insufficient valve-to-valve clearance, there are more than a few additional pitfalls for the hot rodders to run into when attempting this seemingly straightforward modification. The problem most often unforeseen is that a larger intake valve can come very close to the edge of the chamber. This close proximity of these surfaces near the valve head, often called valve shrouding, increases low flow restriction and usually reduces flow. Goes on in yellow, and it always has a negative effect on flow in mid to high range. And then more down here, when larger valves are installed, shrouding can often be reduced by grinding the combustion chamber or the top of the cylinder bore. If shrouding is not reduced to the level that extent with the original valve size, there may be little or no increase in flow, and there in some cases, larger valves can actually reduce low mid flow. So this just goes to show you why all of my cylinder heads are backed by research. I tell you the truth. I'm not selling you anything. People that choose to come to me and get a cylinder head, I'm thinking they're coming here because they want the best. Now, when you look at this port shape and when you look at this port shape, you've already seen how at a lift, this thing is still shrouded. Let's look at this valve at a lift. Does that appear to be shrouded in any way? If you had to choose between one combustion chamber design or the other, which one would you choose? So, until next time, guys, I'm Paul from Paul's Karts. Hope you guys enjoyed this video. I did this video just to bring the knowledge to the people where the knowledge is needed. Like my show says, dedicated to research. I'm Paul. This is Paul's Karts. Please like and subscribe. And for any projects or information, please call 781-492-7358. And until next time, have a nice day.